This is a standing wave pre-lab video. The write-up that you're going to need to bring in to do the lab will have to have on it the title, which should be the standing wave lab, the purpose, which should be to investigate the relationship between harmonics, frequency, and wave speed, the materials, and you're going to have to list the equipment. I'll show you that in the video next. The equipment setup. After you watch the first part of the video, I want you to draw and label a sketch of the equipment in its final setup. The procedure, you're going to have to list a very short procedure. I'll talk you through it after going through the equipment setup. The data collection, you're going to have a data table in the write-up that you bring in. The data table will obviously be empty, and you're also going to need to have drawings in this section. And they have to be done before you bring it in. I'll talk you through it after going through the procedure. You'll fill in the data table during the lab. Analysis. You're going to complete a brief analysis after you do the lab. I'll discuss what you should include in this section after going through the data collection in the video. The materials you need include the physics stand, which you need to set up, string, it's going to be elastic string, so it should be out, a thing called a wiggler, which is going to wiggle the string, and a thing called the fiddle head, which you're going to attach the string to. You're going to need a timer, which you'll pull out of the box. So the timer, you're just going to need the timer itself, a phone cord, and obviously the power supply. We don't need to use the photocells on this. And you're going to need to get a new piece of equipment called the sound and wave machine. So I've shown you there the box that it comes in and what it looks like after you get out of the box. And that's all the material that you'll need. After you gather the equipment, you're going to take the wiggler and see how it's got this little knob attached to it right there. You're going to take that knob off. Then you're going to take the wiggler and you're going to attach it. You want to make sure the wiggler hook is at the top of the wiggler, so it's pointing up towards the ceiling. And you're going to attach it here in the bottom two slots of the physics stand. Here's a picture of the wiggler correctly in place. We've got the knob back on now, holding it in place. The wiggler comes in from the other side, and we can see this little tiny slot that helps to hold it in place. And obviously this little hook right here is pointing up towards the ceiling. Next, it's easier to get the fiddle head on if you place the stand on the floor. So go ahead and place the stand on the floor, and we're going to grab the fiddle head. Again, you're taking that knob off of this long screw, and you're going to put the fiddle head in the top two positions on the post. So the fiddle head just slides right in there. After you get it in there, you're going to take this knob and hook it up and tighten it down in. So here's a picture of the physics stand with the fiddle head and the wiggler in place. And now it's kind of obvious why this is called a fiddle head, because it kind of looks like a bass fiddle. And the wiggler is because it's going to actually wiggle the string. So next you need to string it. Leave the physics stand on the floor so you can put the string on. You're going to take the end of the string that has a loop there, and you're going to take it over by the wiggler hook, and you're going to go ahead and just hook it right into that wiggler. So it's hooked into that notch. It should be fairly secure in that notch right over here. You're going to pull it up so it's level with the bottom of the fiddle head, okay? And just pull it so that the string is reasonably loose. It should not be real tight, but it also shouldn't have any extra string flopping around. Once you get it to that position, then you want to make it tight. So holding it there, so you've got just that right of string, then you're going to pull it up so that it's now tight somewhat, and you're going to go to the key of the fiddle head. You're going to have loosened this bolt here, and there's a whole bunch of washers in here. You're going to take the string and wrap it around the washers. There'll be some hanging out. And then you're going to tighten this bolt down, and the friction will hold it in place. Do not tie a knot on the string. The key will use friction to hold it in place. A knot would be a very, very bad idea. So this is going to be a real shaky video showing you how to tighten that up. So there I have the string, reasonably tight, not real loose or not real tight. And there I am wrapping it around those washers, and then I'm going to tighten that bolt and make sure that friction holds it in place. And then that extra string you can just kind of wrap around, get it out of the way, wrapping it on that top thing. For your procedure, what you're going to do after you set the equipment up is, one, find a strong harmonic. A strong harmonic is one that is easy to find for you. There's going to be multiple harmonics on these strings. You're going to just do it by fiddling around with that frequency knob, which I'll show you in a minute. You're going to determine what harmonic it is by counting the antinodes. Remember, the number of antinodes is a harmonic number. You're going to write down the frequency of that harmonic. You're going to measure the actual wavelength with a meter stick. You're going to determine the speed of the wave using the equation V equals lambda F. And you're going to continue until you have found the first 6 harmonics. And then if you want to, you can do 2 more. You go back to the first harmonic, dial in the frequency for it, and observe its amplitude. So get an idea relative in your mind of what the amplitude looks like. And then you're going to go to the second harmonic and see how that amplitude compares and write it down in your lab table. And then you go to the third harmonic and see how that compared to the second one, and the fourth and the fifth, and so on until you've done the first 6 harmonics. So you're just comparing the amplitude of the higher harmonic to the one right below it. Is it bigger? Is it smaller? Is it the same size? What's going on? Then you're going to turn off the wiggler, loosen the key, and pull up on the string another 3 to 5 inches so it's tighter. We don't want it too tight, but 3 to 5 inches more, make it a little tighter, and then rewind it and tighten the key down and repeat the first 8 steps with the tightened string. So you'll be taking more data a second time. Your data table will have this many columns. You're going to have a drawing of the harmonic. You're going to have the harmonic number, and you can go ahead and fill in the harmonic numbers now. A predicted wavelength, and we're going to fill that in a minute. The measured wavelength, you're going to do that in the lab. The frequency, you're going to do that in the lab. The velocity, you're going to calculate that in the lab. And the relative amplitude, again, you're going to find that out in the lab. Okay, the drawing of the harmonic, I'm going to do off to, you're going to put over in here, but I don't have enough space on my computer screen to do that, so I'm going to draw mine over in different locations so I can do them more clearly. The first harmonic has 1 antinode, and it's got 2 nodes. So I'm going to draw the 2 nodes, and I'm going to draw the antinode. So I'm going to draw a crest coming in here, and then I'm going to draw the return path with a dotted line. My second harmonic is going to have 3 antinodes, so I'm going to draw in my 3 antinodes. I'm going to start with a crest, then a trough, and then it's going to be reflected back with a dotted line. My third harmonic is going to have 4 antinodes, so I'm going to start with a crest, a trough, a crest, and then I'm going to draw the reflection coming back. Okay, my fourth harmonic is going to have 5 antinodes, so I'm going to draw a crest, a trough, a crest, a trough, and then I'm going to draw the reflection coming back. The fifth harmonic is going to have 6 antinodes. I'm going to draw a crest, a trough, a crest, a trough, a crest, and then I'm going to draw the reflection coming back. My sixth harmonic is going to have 7 antinodes, so I'm going to draw the 7 antinodes. And I'll have a crest, a trough, a crest, a trough, a crest, and a trough, and I'll draw that reflection coming back. Now, to make it easier for you to see, I drew them really big, but you're going to have to put all of them over into your first column. So you want to make that first column fairly long, and it would be nice if they were all stretching across the first column. Predicting the wavelength. When we have our fiddle head set up correctly, okay, the length of that string is exactly 1 meter. So on my first harmonic, I have half a wavelength. So half a wavelength is equal to 1 meter. And you solve for the wavelength. For my second harmonic, I have 1 wave, And so 1 wave is equal to 1 meter. Oh, that one's easy. On my third harmonic, I have 1.5 waves is equal to 1 meter. So I solve for the wavelength. On my fourth harmonic, I have 2 waves, and that's equal to 1 meter. And so you solve for the wavelength. And you go ahead and go through all 6 of those. And you repeat it again for the next one. They're all equal to 1 meter for the full thing. How many waves they are, you're going to get from going back to those drawings. So on my first harmonic, I can see I only have 1 antinode, and this is just half a wave. My second harmonic, I have a full wave. Third, I have 1.5. So those pictures come in handy for that. In the conclusion, you should explain what happened to the wavelength as you went to higher harmonics, the velocity as you went to higher harmonics, and as you changed the string. So what happened to the velocity as you went to higher harmonics and as you changed the string tension? What happened to the frequency as you went to higher harmonics? What relationships there might be between the harmonic number and the frequency of that harmonic? What relationships there might be between the frequency of the higher harmonics and the fundamental frequency? The fundamental frequency is also called the first harmonic. For each of these points, and there's 5 points, you need to include at least 2 specific examples, and that would be evidence from your lab results that illustrates or proves your explanation.